Today, we'll be going over how to use a Punnett square to determine the probability that an offspring will have a trait based on the phenotypes of the parents. First, let's start with the problem. Both of Jimmy's parents are heterozygous for brown eyes. Capital B signifies the dominant brown trait, while little b is the recessive blue trait. What is the probability that Jimmy has blue eyes? This slide tells us what Jimmy's parents' genotypes are, but how would we write them out? If both of Jimmy's parents are heterozygous for eye color, what is their phenotype? Let's remember that heterozygous means that the two alleles are different. If the two alleles that code for eye color in this problem are capital B and lowercase b, then both of Jimmy's parents will have the genotype capital B, lowercase b. To start a Punnett square, draw a square made up of 4 boxes. Another way to think about this is to draw a large square, then draw a vertical line down the middle and a horizontal line down the middle. Recall the genotypes of Jimmy's parents. Put the dad's genotype down the left side and the mom's across the top. Each allele should have its own square, except for the top left square, which is shared between 2 alleles. Starting with the mom's dominant allele, the uppercase B, write it in the 2 boxes immediately below it. Do the same with the mom's recessive allele, the lowercase b. The red arrows show where the allele should be written in the box. Next, follow the blue arrows to write the dad's alleles. Starting with his dominant allele, write it in the 2 boxes to the right. Do the same for the recessive allele, writing the lowercase b in the 2 boxes to its right. Now that you have made the Punnett square, you are able to see all the possible genotypes of Jimmy's parents' offspring. The next step is to calculate the ratios of each genotype. As you can see, only one of the 4 possibilities are homozygous dominant, meaning that both alleles are the same with the dominant allele. 2 out of the 4, or 1/2 of the genotypes, are heterozygous, and 1 of the 4 are homozygous recessive. The next step is to find the phenotypes and their probabilities. The genotypes, and their probabilities. Whenever a pair of alleles has a dominant allele, it will express a dominant trait, regardless of if it's homozygous or heterozygous. The only time that allele is expressed is when it is homozygous. In this Punnett square, 3 of the 4 genotypes have a capital B, meaning that 3 of the 4 pairs of alleles code for brown eyes. The remaining allele pair is homozygous, which indicates that 1 of the 4 code for blue eyes. Let's consider the question again. Both of Jimmy's parents are heterozygous for brown eyes. Capital B signifies the dominant brown trait, while the lowercase b is the recessive blue trait. What is the probability that Jimmy has blue eyes? To find the probability of Jimmy having blue eyes, we'll have to find the percent of the alleles that code for blue eyes. We found on the previous slide that 1/4 of the genotypes code for blue eyes. To convert this number into a percentage, divide 1 by 4. This will give you 0.25. Next, multiply that number by 100, and you have your percent. To answer the question, Jimmy has a 25% chance of having blue eyes.